In this video, we'll see how to traverse a linked list. Traversal means visiting each node exactly once. So we'll start from the first node and visit each node till the last node. Before studying traversal, let us first see how we can move a reference forward in a linked list. Suppose we have this reference P that refers to this node. Now this is P link. It refers to this node. Now if we assign P link to P, then P will start referring to this node. So writing this statement P equal to P link makes P refer to the next node of the list. Or we can say that P has moved one node forward in the list. So this is the statement that we'll repeatedly use to traverse our list. Okay, now let's see how we can traverse our linked list. We have to start from the first node. So we'll take a reference P that refers to the first node. To make P refer to the first node, we initialize it with start because start refers to the first node. Now while visiting each node, we'll print the contents of the node. Now P refers to this node, P info is 10, so 10 will be printed. Next we write P equal to P link, so now P will refer to this node, and now when we print P info, 20 will be printed because info of this node is 20. Now again we write P equal to P link, P refers to this node now, and now P info is 30, so 30 will be printed. Again we write P equal to P link, P refers to this node. Now this time 40 will be printed. Again we write P equal to P link, P refers to this node. Now when we print P info, 50 will be printed. Again we write P equal to P link. Now this time P will become none. So we have reached the end of the list and we can stop. So we have traversed the whole list and printed the list items. We can see that we are repeating the same statements again and again. So we can write this in a loop, and the terminating condition for that loop would be when P becomes none. So this is the loop for traversing a linked list. We take a reference P and initialize it with start, and this loop continues till P is not none. When P becomes none, this loop will terminate. In each iteration, we are printing the value of P info and we are moving P forward by assigning P link to P. So this is how we can traverse a list starting from the first node till the last node. We can use the same loop to count the number of nodes in the list. Here we have taken this variable n and initialized it to 0. And whenever we visit a node, we increment the value of n. So when this loop terminates, the value of n will give us the number of nodes in the list. Similarly, we can use this loop to search for an element in the list. Now let us go to our program and see the methods for displaying a list, counting number of nodes, and searching for an element in the list. So we'll see the code for these three methods: display list, count nodes, and search. This method display list displays all the elements of the list. If a start is none, it means that the list is empty. In that case, we'll just print this message and return. Otherwise, we'll display all the elements of the list starting from the first element till the last element. We have already seen how this loop works. Now this method count nodes displays the number of nodes in the list. If you want, you can return the value of n from this method. Now this method search will return true if this element x is present in the list. Otherwise, it will return false. Let's see how this method works. We have taken this variable position and initialized it to 1. We'll increment it each time we visit a node. This reference P is initialized with start, and this is the same loop that we have seen in these two methods. So we are actually visiting each node starting from the first node. This is statement P equal to P link makes P move forward. Now whenever we visit a node, we check info of that node, and if info of that node is equal to X, then we return true from this method, indicating that X is present in the list. And before returning, we print this message that displays the position of X in the list. If P becomes none, it means that we have reached the end of the list and X was not found. So in that case, control will come here and we'll print this message and return false. Now let's see the method calls. We've called these three methods in options 1, 2 and 3. If we select option 1, list will be displayed. If we select option 2, number of nodes in the list will be displayed. And if we choose option 3, we can search for an element in the list. Now let's try to run this program. First we choose option 1. It is displaying that the list is empty. Next we choose option 2. It is displaying that number of nodes in the list is 0. Next we choose option 3. We search for an element. It is saying that 45 is not found in the list. Since our list is empty, whatever element we search, it will say that it is not found in the list. We choose option 19 and exit. Now here we had created a new single linked list instance, and in the init method we have initialized start to none. So the linked list that we have created here is actually empty. After that we have called this method create list that will actually insert some nodes in the list, but we have not written the code for it yet. So that's why when we came here the list was empty. In the next few videos, we'll see how to insert nodes in our list, and we'll see the code for this method, create list. So right now your task is to write the code for these three methods: display list, count nodes and search. So see you in the next video.